Hey everybody. We're on the final question type that I'm going to go over with regards to complex inheritance. So far, we've been over codominance with multiple alleles. We've been over just codominance with two alleles. And we've been over incomplete dominance, where you sometimes see in the heterozygous genotype a phenotype that is expressed that is somewhere in between the two homozygous genotypes. So looking like a mix or in between. All right, the final example here is number 8. And this deals with genes that are located on sex chromosomes. Number 8 says, Fragile X syndrome is a sex-linked disorder on the X chromosome. Not having the disease, represented by a capital H, is dominant over having Fragile X, lowercase h. This means that having Fragile X disease is recessive. Being normal is dominant. It says create a Punnett square for a cross between a normal male and a female with the disease. So first thing we'll want to do is create a Punnett square. And something else you might want to do, and this is me just reminding you guys, for a male and a female let's look at their sex chromosomes. A male is always going to be XY. A female is always going to be XX. When you're looking at sex-linked disorders or sex-linked traits, you're always going to be crossing a male and a female. It's always going to look something like this. Now, I could have chose to put the male on the left side and the female on the top, the male on the left side, wherever. Doesn't matter. It'll all cross out the same. All right, so we know the two sexes and what their sex chromosomes look like. Let me remind you, the Y chromosome on males, it will not contain genes, at least the genes that we're going to be talking about, okay? So you will never put a letter connected to a Y chromosome. Let's also write down what our two possible alleles are. So you can have a big H, which represents being normal, or you can have a little h, which represents having Fragile X, the disease. Okay? And I'm actually going to color this little h a different color. Let's color it red, because I want to follow it. It says, create a Punnett square for a cross between a normal male and a female with the disease. All right, before we do this, I want to give all the possible combinations over here that we can have. And let me do this first. Let me write them one at a time. All right, so a female can have both normal alleles. She can have one normal allele and one Fragile X allele, or she can have two Fragile X alleles. Okay? A male is either going to be normal with the normal allele or have Fragile X. Now, let me go ahead and highlight the Fragile X alleles in a different color. All right, so one thing I want to be clear with, this is a female who does not have the disease. We consider this a normal female, okay? Here, this is a normal female. She will not have the disease. However, she is considered a carrier because she is carrying the allele. Remember that sex-linked traits still follow the rules of dominance. They follow the inheritance pattern of complete dominance. So you have recessive alleles and dominant alleles. In the heterozygote, the dominant allele is going to overshadow the recessive allele. So you can have a normal female, a carrier female, or a female with the disease. Males, because they only have one X chromosome to carry this trait, to carry these alleles, he's either going to be normal or he's going to have the disease. Okay? So our Punnett square once again asks for us to cross a normal male with a female with the disease. So the female with the disease is going to have both recessive alleles for the disease, and the normal male is only going to have the normal allele. Let me color up those fragile X alleles, the recessive fragile X alleles, and let's do our cross. So you got an X with a big H and an X with a little h. X with a big H, X with a little h. X with a little h and an X with a Y, X with a little h and a Y. I don't know why I said X with a Y. Let's highlight our fragile X alleles, the recessive alleles, once again. And let's look at the probabilities. I'm going to move this stuff over. All right. And what we have here is we have 2 out of 4 of our offspring being females that are carriers. Or 50% are carrier females. Then you've got 50% chance that the offspring is going to be a male with the disease. So 2 out of 4, 50%. One thing I really want to highlight here is when we talk about sex-linked traits, a repeating property, something that comes up all the time, is that the males are going to express more. They're going to express a trait more, just in general. Because look, even though the female had the disease, the female mother, and the male was completely normal, the only offspring to receive the disease were the males. Okay? And it has a lot to do with the males only having one X chromosome and only having 2 possible genotypes. So, with sex-linked traits, males are going to express the disease more often. That is very important for you to remember. All right, so let's finish up this problem. It says circle all phenotypes. So let's circle the ones that are present. Are there any normal males present in the offspring between this cross? No. Are there males with the disease? Yeah, there's 2 of them, 2 out of 4. Are there normal females? Now you might think yes, and you would be correct, that if we're talking about the phenotypes, yes, there's 2 normal females. But let's look at the other option over here, carrier females. Are these normal females in the offspring or carriers? That's right, these are carrier females. So we need to circle or put a box around carrier females. Are there any females with the disease? No. The mother had the disease right here, but no offspring females had the disease. We only had carrier females. What's the percent of offspring with the disease? Just those 2 males, so 50%. What's their gender? Like I said, they are males. All right. That does it for my review of inheritance patterns, especially complex inheritance patterns. We went over sex-linked traits. We went over codominance with multiple alleles. We went over codominance with just 2 alleles. And we went over incomplete dominance. Hopefully this was all clear and helpful. If you guys have any questions, just talk to me. Have a good rest of your day.